The third grade in PVC or polyvinyl chloride cables, the third grade is heat resistant or heat resistance PVC. Because of use of monomeric plasticizer, which volatilize at temperature 80 to 100 degrees Celsius, the general purpose type compounds become stiff, they become hard. So there is a chance of breakage in the insulation, which is not able to solve our purpose. So by using polymeric plasticizer, it is possible to operate the cable continuously around 100 degree or more than 100 degree Celsius. It is the manufacturing, or it is the principle of manufacturing of heat resistant PVC cable. The next one is XLPE. XLPE material can be used for high frequency cables. XLPE stands for cross-linked polyethylene. Cross-linked polyethylene or ethylene. This material is used for insulation of cable. It does not melt on high temperatures. It does not melt on high temperatures. That's why it is used for most of the cases when we are using a cable for distribution side. In the picture shown, you can see, you are able to see there is a 4-core cable where 3 cores are clad with XLPE insulation, where the fourth is bare. It is generally used for distribution side. The clad cores are generally used for phase cables, whereas the bare conductor or bare strand conductor is used for neutral conductor. This is just because of some cost effectiveness. If we are able to pay, you can clad the fourth cable, that is neutral wire also. This polythene is inert to chemical reactions. It does not have double bonds and polar groups, so it is more effective for cables manufacturing or insulation of cables. The next thing is insulation resistance of cable. We know the general formula of insulation is resistance is R is equal to rho L by A. It is also applicable for the insulation resistance of cable also. Here rho is specific resistance of the material, L it is the length of path of current, and A it is cross section normal to flow of current. In this case, the usual load current flows through the core of cable, whereas the leakage current will flow outward, means radially from the core to the sheath, and we are going to calculate the resistance of that part only from the conductor to the sheath through dielectric material. That's why it is written A cross section normal to the flow of current, means flow of the load current. If we move from core to the sheath, expression for insulation resistance of an annular cylinder, let's say the radii of insulation start from x and ends to x plus dx, means x is inner radii and x plus dx is outer radius from the center of core, and we are taking an sample of unit length of the insulated cable. So dr will be rho into dx upon 2 pi x into 1. Dx is length or small length, whereas 2 pi x into 1 is area. Dx is the replacement of L, whereas 2 pi x into 1 is equal to replacement of A in this general formula. So if we integrate for the whole section, it will be R is equal to rho upon 2 pi integration within the limits small r to capital R, that is small r to capital R. Small r is radius of the conductor, whereas capital R is radius of whole insulated cable. R is equal to rho upon 2 pi integration small r to capital R dx by x. it will give us the result R is equal to rho upon 2 pi ln capital R upon R ohms per meter. In case the length of cable is L units, the leakage resistance will be R is equal to rho upon 2 pi L ln capital R upon small r expressed in ohms. It is a very important formula. On the basis of this, there are so many examples or so many numericals which have been asked in previous competitive type exams, or it is useful for your university exams also.